Welcome to CS 1401 video 12.3. In this video, I'll look at white box testing of software. In white box testing, there are four kinds of internal processes for which we should design test cases. The tester can design test cases that 1. Try out the independent control paths within a module, try out logical decisions for both their true and false cases, 3. Execute loops at their boundaries and within their operational bounds, and 4. Try out internal data structures to ensure their validity. And there are also multiple systematic methods for designing the test cases for each of these four categories. I want you to remember that these methods are available, but for our purposes in this course, they're too advanced. But I want you to know that the very process of using these advanced approaches to designing the test cases is useful by itself. Indeed, pursuing careful, complete, and systematic test design will catch as many bugs as the testing using the design. In other words, the test design process is as effective at catching bugs as is running the test cases designed by that process. At this point in our studies, let's focus on designing cases that test logical decisions and test the boundaries of control loops. For example, let's try white box testing of logical decisions for my month, name, and length program. There's one logical test, and it's a compound test. Is month number less than 1, or is month number greater than 12? We can create test cases around these values that are used in the logical expression. In the first part of the logical expression, the greatest value that makes the test true is 0, and the smallest number that makes the test false is 1. So we'll use 0 and 1 as test cases. Likewise, for the other part of the test, 12 is the greatest value that makes the test false, and 13 is the smallest value that makes the test true. So we'll also use 12 and 13 as test cases. And now we can see why I chose these values as test cases in the video on conditionals. Let's try them out. 0 has the program report an invalid month. 1 produces January in 31 days. 12 produces December in 31 days. And 13 produces invalid month. My program passed all four white box test cases, and we can be confident that I wrote my logical test correctly. If one of my test cases had revealed a problem, using white box testing means we know exactly which lines of code to check. This makes problem solving much easier in white box testing than in black box testing, where the test itself doesn't connect to the program's internals. As an example, here's another version of my program that counts from a given number down to 1. So I've called it countdown yet again. For purposes of white box testing, when we look inside the program, we can see the loop boundaries. I starts at the number, and the loop executes until I is greater than or equal to 0. This means that we can devise a couple of cases that check out the loop boundaries. First, we'll try the number equals 0, and then the number equals 1. When I run the program with argument 0, it prints out 0. That's an error. The program is supposed to count down to 1, not 0. And when I try it with an argument 1, I get a similar result. The program counts from the given number, in this case 1, down to 0. It should just have printed 1 and then done. These results mean that the loop boundaries have an error. The start of the loop seems correct, but the end of the loop seems incorrect. When we look back at the code, we can see that the loop condition for the for loop should have been I greater than 0, not I greater than or equal to 0. Well, that's an introduction to software testing. We'll look at white box testing and black box testing. In the next class, we'll look at what to do when testing indicates that there's an uncovered case, or we simply run into a problem with our program. See you then.